Okay, I'm going to go over the homework from section 17, these three of these problems. So the first problem was to evaluate this double integral. And it's a double integral where the integrand is 2. And it's over a certain area, a certain region in the xy plane where x is between 0 and 2 and y is between 0 and x. So in the xy plane, it looks like if you draw the line y equals x and y equals 0 and look between 0 and 2, you're going to have a triangle. So this is what the picture looks like. You can see that x is between 0 and 2. You should try to imagine fixing x and look what happens with y. Y is going from the bottom to the top here. So from 0, y equals 0 is the x-axis, to y equals x, which is this line. So we're going from 0 to x. The solid itself looks like this. Again, you can see the triangle in the xy plane. And the height of the solid is 2 because that's where we're integrating. Z equals 2 is the plane that's giving us the height. So we're up here at z equals 2 for this plane. So to find the volume of this solid, what we're going to do, we don't know a lot. This is just the first introduction to multiple integrals, and all we know is that this is the volume of the solid. So we want to figure out what the area of the base is, and then multiply by the height. Or another way of thinking of this is that you can think of this as being 1/2 of a box, and this is the base. If I were to include this triangle up here, you would just be getting a box that's a 2 by 2 by 2 box, that's the height. So it's 1/2 of 2 by 2 by 2. Or if you do the area of the triangle, it's 1/2 2 times 2 for this area times the height, which is 2. So the answer again is you take the area of the box, say that's 2 by 2 by 2 and 1/2 of that, or you can take the area of the triangle, 1/2 2 times 2 and multiply by 2. The answer is 4. So that's the answer to this problem. Let's look at this double integral for number 3. What does it tell us? R is the region in the first quadrant bounded by the circle x squared plus y squared equals 1. And the coordinate axis, but that's part of the first quadrant here. So we have the base is this quarter of a circle in the xy plane. Quarter of the circle, the x squared plus y squared equals 1, and we're in the first quadrant of the xy plane. And the integrand is just 1 here. So dA, you should think of as 1 dA. You have one of them, after all. So it's just 1 dA. And so the height is z equals 1 is this plane. So we just have a height of 1. So how do we calculate that volume? Well, we have 1/4 of a cylinder. The area of the base is pi r squared times the height, which is 1. So this will be the height of our solid, 1. This is z equals 1 on the top. And we have this quarter of a circle on the bottom. And so we have 1/4 of a cylinder. The volume of a cylinder is pi r squared h. So the h is going to be 1, and r, the radius, is 1. So we want 1/4 of that because we only are in the first quadrant for our circle, or in the first octant for our cylinder. So this is just going to be 1/4 of the cylinder. So it's 1/4 pi times 1 squared times 1, or just pi fourths. So pi fourths is the volume of this solid. And that answers number 3. So let's look at number 7. Here, the region we're integrating over is a rectangle. X is between 0 and 4, and y is between 0 and 2. But we see this is a piecewise function. F is defined differently in different parts of this rectangle. So let me draw a picture. I have y between 0 and 2 and x between 0 and 4. For each x between 0 and 3 in this range, and y between 0 and 1, so just this part here, the function is 2. So I'll shade that in and put a 2 there. And for x between 0 and 3 still, but now y between 1 and 2, so these three squares here, the value of the function is 1. And finally, when x is between 3 and 4, so right here, and y is between 0 and 2, so that's giving both of these squares, the value of the function is negative 3. Okay, so this tells us that the height for this part is 2, and so for this part by itself, we'll have a box that's a 1 by 3 by 2 box. The height will be 2 here. For this part, we'll have a box that's 1 by 3 by 1. The height will be 1 here. Here we also have a box that's below the xy plane because z is negative, but it's a 1 by 2 by 3 box that's below the xy plane. We're going to have to subtract this volume when we're doing this double integral. Okay, so we have 1 by 3 by 2 here, a 1 by 3 by 1 here, and again, we have a 1 by 2 by 3 here, but it's below the xy plane, so we'll have to subtract that. So we have 1 by 3 by 2, a 1 by 3 by 1, and a 2 by 1. I'm putting minus 3 here because the height's negative if you want, but you have to subtract that volume. That gives us then 6 plus 3 minus 6. So we get just 3 there, and 3 then will be the value of this double integral. So the value of this double integral is this. From here, we got the 6. From here, we got the 3. And from here, we got the minus 6. And so the total value of the double integral is 3. And so that's our answer. And that finishes this lecture.